Hello everyone. Today we are going to see very important activity or experiment for class 10th. What is this activity? The activity is refraction of light through a rectangular glass prism. Okay, so this activity is very important for class 10th. Okay, you have to do this as an practical. Okay, during main exam you have to do it as a practical during main exam and you have marks for that. And second important thing is when you write your exam, okay, written exam, in that there is a fair chance that 1 mark question can be answered from this 1 mark. Okay, first to 20 questions, what you have, first to 20 questions, what you have MCQs, right? So 1 mark question can be answered from this concept. And also there's a fair chance, if that is not asked, there's a fair chance that a 3 marks question can be asked. Okay, 3 marks question can be asked from this topic with or without a paragraph. They may give paragraph, they may not give paragraph, but a 3 marks question may be asked. So if you are good in this, you can do your practical well, get marks there. And also that 1 mark or 3 mark question which is going to come in your exam, you can also answer it very well. So let me explain what I have drawn in this board. Here the glass slab, okay, we are taking a rectangular glass slab. So this is a rectangular glass slab. I have a rectangular glass slab. So what is this rectangular glass slab? Let me explain first. So by the name itself you are seeing that it's a glass slab. Glass slab means a slab, okay, cuboidal structure made completely with glass. A cuboidal structure made completely with glass. That is my glass slab. So what is the material here? The material here is glass. Okay, uniform, homogeneously made with glass. No other medium inside it, completely filled with glass. Inside fully glass. Okay, so this is a cuboid, right? This is a cuboid. Cuboid has how many corners? Just a basic question I am asking. Cuboid has how many corners? 8 corners. So I have written name for them: A, B, C, D. Okay, E, F, G, H. Okay, there are 8 corners, right? 8 corners. I just named them for your sake of understanding. Okay, right now I don't have a glass slab with me, but I am trying my best to make you understand how to do this experiment and what are the results we can expect from this experiment, and what is the meaning of those results which we get. Okay, what does they mean, what does they imply? These things I am going to explain. So this video is going to be a little long, just bear with me. So we have a rectangular glass slab here, Now, see that if I see this glass slab from top, okay, I have kept on this plane a glass slab and I am seeing it top. So what would be visible to me? Only the face A, B, C, D will be visible to me, correct? Only the face A, B, C, D will be visible to me, right? So that A, B, C, D I have drawn it, I have enlarged it because I need to draw a ray diagram here. So that's why for that sake, the same glass slab I had drawn here, but I have enlarged it, okay, magnified it for you so that you can clearly see the ray diagrams. Okay, so this is the face ABCD. This is the face ABCD when I am seeing it from top. So if I see the same glass slab through, okay, if I see the same glass slab this way, okay, try to see it through this face. Which face? AEFB. Try to see it through AEFB. How does the glass slab look like? That diagram I have drawn here. The glass slab would look like this. Okay. If I see the glass slab through EFBA, or you can say AEFB, or any name you can say, ABFE, any name you can say. But if I see it from this side, it is going to look this way. BFE. Okay, the glass slab is going to look this way. So I have drawn the same glass slab. How it is going to look from the top? Okay, this figure, and how it is going to look if I see from side, that is this figure. Clear? So this figure same belongs to the same rectangular glass slab. Top view, this is the top view, this is I am seeing from side, so I can say it as side view. Clear? I hope this is clear. Up to here it is clear. Now let's when you are doing this experiment, the experiment will have a title, right? Will have a title. What do we call it? We will call it as aim of the experiment. What is the aim of the experiment? The aim of the experiment is to trace the path of light passing through the glass slab. What is the aim of your experiment? To trace the path of light passing through the glass slab and to find angle of incidence, angle of refraction and angle of emergence, and also interpret the results which you see. Okay, interpret the values which you see. Angle of incidence, you will get the value of angle of incidence. Angle of refraction, angle of emergence you are going to get. I'll show it. Don't worry. So those, what is the interference when you get the value? So what you can conclude from those points, those things, that is aim of our experiment. Also aim for this video. Clear? The aim is to trace the path of light passing through glass slab and find angle of incidence, angle of refraction and angle of emergence. Okay, and also interpret the values which we get. Okay, to conclude, what can we conclude from that? That is our aim. Then after aim, what you write? You write materials required. Correct? So what are the materials required? Materials required. So what are the materials required? Materials required. Number one, you want a drawing board. You want drawing board. Number two, drawing pins. Okay, drawing pins, or you can, people also say it as thumb pins. Drawing pins or thumb pins. Okay, you'll apply force. Okay, you'll apply thrust using your thumb, right? Thumb pins. Next, glass slab, rectangular glass slab. Next, all pins. Okay, you want 4 all pins. Okay, you'll require 4 all pins. Next, pencil, scale and protractor. Drawing board, pins, glass slab, all pins, 4 number, pencil, scale and protractor. So these are the materials required for this experiment. So let me tell you what are the functions of these things. Drawing board. Okay, and most important thing we forgot, what is that? This white sheet of paper. Okay, better if you take A4 or A3. Okay, better if you take A3, you can this experiment has to be repeated 3 times. Should be at least 3 times you have to repeat this. 3 times you have to repeat it. So I would suggest you take A3 paper. On A3 paper you can draw 3 times. You can draw do the activity 3 times in A3 paper. Or if you take A4 paper, you require 3 A4 papers, and on that you have to do it. So let me see what is the function of a drawing board. Drawing board, you require to place your white sheet of paper on it, right? Next, these pins you are using it to fix the paper on the drawing board. Clear? Glass slab. Through glass slab I am going to see the refraction of light. I'm going to see the how the light going to pass through the glass slab. So this is our main hero. Who is our main hero? Glass slab. And supporting characters, all pins. Okay. Then all pins. I hope that you know what are all pins. Okay. Most times students ask me what are all pins. Okay. So what are the pins? Let me. All pin looks like this. All pin will have a small head, and it's very thin body. Okay. Very small head, and very thin body. Its height would be around 1.5 centimeters. Its height would be around 1.5 centimeters. What are the other types of pins you have? So it's very thin, right? What are the other types of pins you have? This pin, drawing pins. Okay, these are drawing pins available in the market. Right, one pin will look like this. The other type of pin, thumb pins. So thumb pins are shorter one. Thumb pins are shorter one. And I suggest you to use the all pins only, not these drawing pins. Don't use them. Okay, don't use them. I'll tell you why you should not use them. Okay, later in this video. But don't use them. If you don't have, then okay. But if you want accurate results, don't use this drawing pins. Use only all pin. How many all pins you want? 4 number. Pencil, scale, protractor, these things you know. Correct? So let us go into the activity. So now I am going to explain you the procedure of the activity. Okay? Procedure. So what is the procedure? Number 1. Take a drawing board. On the drawing board, fix the white paper. Simple. Take the drawing board, fix the white paper. Okay, using drawing pins or thumb pins. Next, after that, at the center of the page, place the glass slab. Okay, place the glass slab at the center of the page. Place the glass slab and take the outline of the slab. That is your step 2. At the center of the page, place the glass slab and take the outline of the glass slab. So how is the outline going to look? Take the glass slab, keep it middle, draw the outline. How is it going to look? Rectangle. That's why we are calling it as rectangular glass slab. Right? And I have written the names for that also. A, B, C, D. If you can, okay? If you can see here, I have written the name also. A, B, C, D. That is what I have written. Clear? So on this sheet of paper, I have kept a glass slab and I have taken the traces. Okay, I have taken the traces, the boundary. I have traced the boundary of it. Okay. So in this activity, many times I need to remove the glass slab and place it. If I don't draw the outline, I cannot place it properly in the same position. That's why I'm drawing the outline. And also, if you really want to see how the light is bending, then without outline you cannot judge. So that's why drawing the outline of glass slab is very, very, very important. After drawing the outline of the glass slab, remove the glass slab from the paper. Okay, remove the glass slab from the paper and choose a point on the side DC. Choose a point on the side DC. Okay, anywhere you can choose. I am leaving it to you. Anywhere you can choose a point DC. Okay, I suggest you that you take the point. Okay, this is my suggestion. Take the point towards D, towards little bit towards left side, towards D. Okay, why? I'll explain it little later. You have to take it towards D. Okay. Then at that point, see here glass slab you have taken out. Now what you have? You have a boundary and you have named them A, B, C, D, right? On the side CD, what you are doing? You have chosen a point, your wish. But I suggest you to take it towards left, little bit left. At that, with the help of protractor, scale and pencil, draw a perpendicular line. Okay, draw a perpendicular line. So I'm drawing here a perpendicular line here. This perpendicular line is normal to CD, right? Normal means perpendicular. So let me name this line so that it would be easy to refer again and again. So name of the line is MN, and let me also name the point as O. Name of the point is O, and name of the line is MN. MN is perpendicular, normal to side CD, correct? Now, with the help of same scale and same pencil, what you do? Draw a line. Okay, draw a line like this. Draw a line like this. How much angle you want to take? Your wish. I am leaving it to you. Okay, how much angle you want to take? I am leaving it to you. But if you take if I want some suggestion, I would tell you to take the angle between 30 degrees to 60 degrees. Okay, this is my suggestion. Take it from 30 degrees to 60 degrees. And why I am saying that 30 degrees to 60 degrees, I'll explain it little later. Okay, so this experiment you have to repeat how many times? At least 3 times. So better to take first case 30, second 45, third. Okay, in experiment number 1 30 degree, in experiment number 2 45 degree, in experiment number 3 60 degree. See, three angles are here. You can take these angles if you want, or it's your wish. You can take any angle, but don't take 0 and 90 degree. And one more important thing, from which line you are going to measure the angles? Are you going to measure the angles with respect to CD or with respect to this line MN? Measure the angles with respect to the lines MN. Okay, measure the angles with respect to the line MN. Please measure it with respect to the line. If you know the laws of refraction, you also know that the angles are measured with respect to normal. The angles are measured with respect to normal, right? So these 30s, 45, 60, which I have suggested, take it with respect to what? Normal MN. Taken? Clear? So this you have drawn it the line. Now how many all pins you have? You have 4 all pins, right? You have all pins. How many numbers? 4 numbers you have. Okay. So take one all pin. Take one all pin and place it on this line. How you are going to place it? You are going to place it perpendicular to the paper. Okay. You have to pierce it inside. Be careful. Do not hurt your arm. Okay. Do not hurt your hand. And moreover, do not bend the all pin. All pin should not also bend. It will bend easily. So do not bend that. Okay. Steadily, smoothly, carefully pierce it. How it should be? It should, if this is paper, that should stand exactly perpendicular. Exactly perpendicular to the paper. Understood? So I have taken pin 1 and I have placed it here. Let me call that pin as P. Let me call that pin as P. So pin P I have pierced on the line, right? On this line which I have drawn. And keeping a distance, pierce another pin perpendicular to the sheet of paper on the line. The pin should be, remember, the pin should be on the line. Okay, so this is P, pin P, this is pin Q. Keeping a distance, how much distance you are going to keep, that's your wish. But I suggest that you keep the distance more than 3 centimeters. Why? I'll explain later. So many things are there which I am going to explain later. What is the significance? So you have taken 2 pins which you have pierced perpendicular on this line, perpendicular to paper. Correct? If I see, okay, next, after piercing them, what you will do? Keep the glass slab again. Take the glass slab and keep it again on such a way that it again in the same position A, B, C, D. Keep it here. Okay. So if you see it from side, view, somewhere here will be pin. pin P. Somewhere here will be pin P. And at some distance here will be pin Q. Correct? When you are seeing it from this face AEFB through this face, pin P will be perpendicular to the paper, right? It is standing there. Can you see that? Pin Q also. Now you have to see through. Now you have to see through the rectangle ABFE. You have to see through rectangle ABFE. I'm drawing. How you have to see? I'm drawing here. See, this is your eye. Okay, this is your eye. And how you are supposed to see? Like this, you have to see it. Your line of sight. Okay, your line of sight. This is your line of sight. Let me draw it clearly. This is your line of sight. I think the gravity is working on the pin. So this is your line of sight. Clear? So that is your line of sight. You have to see in such a way that pin P, pin Q appear to be in a straight line. How you are supposed? You have to adjust. Start seeing from this side. If pin P and Q are appearing through this face, okay, through this, you have to see it through this. You have to see through this. This is very important face. And also part of our experiment. You have to see through this face. See whether P and Q are appearing to be in a straight line. See from here. Yes, no, no. Shift your sight. Is P and Q straight? No. Shift, shift, shift. You have to shift. You have to see through this face. A, B, F, E. You have to see through this face. A, B, F, E. Until you see P and Q as in a straight line. When you are seen, when your line of sight is okay, close one eye. I suggest close one eye and see with only one eye. Close one eye, see with the other eye. Then you can judge properly. You can judge it properly, right? Whether they are in same line or not. So when your line of sight is in the same line with P and Q as seen from ABFE, what I am suggesting is, okay, what you have to do is take another all pin, okay, all pin number 3, and try to place the all pin number 3. Try to place the all pin number 3. Okay, let me name it as R. So this is all pin number 3, R. Now P, Q, R. All the 3 all pins appear to be in a straight line when I see through A, B, F, E. Clear? And leaving some distance. How much distance? This is my suggestion. Take it more than 3 centimeter. Place another pin S. Place another pin S. Now remember, when you see from A, B, F, E, the face A, B, F, E, P, Q, R as all the 4 pins are in a straight line. I am repeating again and again. This is very important. When you see through A, B, F, E, this face A, B, F, E, the pin P, Q, R as all the 4 pins appear to be in a straight line. If they are not in straight line, just make it straight line. That is what you have to do in this activity. All lines should appear to be in a straight line when I see through the face A, B, F, E. Clear? So if I now remove the glass slab. If I see the pins, okay, if I see these pins, if I see it from top, how are they going to look? Okay, how are they going to look? They are going to look what? Only heads will be visible. Correct? Only heads will be visible. So these are those pins. Only heads will be visible if I see it from the top. Okay, just to make sure that okay, let me draw it a little this here. Okay, the gap at least more than 3 centimeters. Keep it more than 3 centimeters. Now, So this is what you will see from top. What you will be able to see, just a top head of the all pin, that's it. Nothing else will be visible, just a head of the all pin will be visible. So it will look like points, right? Now remove the all pins also. Yeah, remove the glass slab, now remove the all pins also. When you remove the all pins, what is left there? Small holes, correct? So using pencil and your scale, using pencil and scale, try to draw it, okay? Try to draw a line such that that joins, draw a line such that that joins the glass slab at side AB and the point of contact, let us call this as O dash. Here I wrote this point as O, so I am writing it as O dash. What did we do? We removed the glass slab, okay, we removed the glass slab, we removed the pins, holes were there. Using pencil and scale, okay, using pencil and scale, I have drawn a line such that it touches the side AB, clear? And that point I have written as O dash. Now join O and O dash. Now join O and O dash, okay, join O and O dash, that's it. So your experiment okay, almost 70% of the experiment is over. 70% of the experiment is over, only 30% is left. So at the point O dash, what you will do is you will again draw normal. Okay, draw normal there. So what is the, let us name the normal, MN, let us name them as M dash, N dash, this is it. So this is what you will get on the sheet of paper. This is what you are going to get on the sheet of paper. See here, the light, okay. So what does this ray indicate? You have seen the all pins all in the straight line, means the light from the all pins. This is what the light from the all pin, or you can say this is line nothing but the light, how the light travels through the glass slab. There is nothing but how the light travels through the glass slab. Now important points. So your procedure is over. Now what are the important points? Okay, your observation table, what does that indicate? Your observation table will have serial number, right, angle of incidence, angle of refraction, angle of emergence, right, and one more column I am writing it here. So angle of emergence minus angle of incidence, these columns will be there in your observation table. So this is my observation table. Angle of incidence, angle of refraction, angle of emergence, angle of, okay, emergence minus angle of incidence. And if your teacher wants to write the lateral shift or lateral displacement, please include that in table also. If your teacher insists, then. If he does not insist, then leave it. So this is your observation table. This is my observation table. Okay, this is my observation table. Now, first thing, what I need to do? How many times I need to do the experiment? 3 times. 1, 2, 3. First, what is angle of incidence? What is angle of incidence? The angle made by the incident ray and the normal at the point of incidence is called angle of incidence. So what is the incident ray? PQ. What is the normal ray? MN. Where is the point of incidence? O. What is the angle of incidence? The angle made by the incident ray with the normal at the point of incidence. What is the point of incidence? This is called angle of incidence. So this is angle of incidence. Clear? This is angle of incidence. Now, angle of refraction. Angle of refraction. So what is angle of refraction? the angle made by the refracted ray, the angle made by the refracted ray with the normal at the point of incidence. The angle made by the, so which is the refracted ray? How is the light entering? This way, right? So the angle made by the refracted ray, this is refracted ray. O dash is refracted ray. O dash is refracted ray. The angle made by the refracted ray at the point of incidence with the normal. So the angle made by refracted ray with the normal at the point of incidence. At the point of incidence, I'll call it as angle of refraction. See here, I have written R here, but I'm writing R1. Okay, I'll explain it. I'll explain that also. Now, see here, what is the outer medium? What is the medium outside? Air. What is the medium outside? Air. What is the medium inside? Glass. What is the medium outside again? Air. So when the light travels from air to glass, when the light travels from air to glass, refraction number 1 takes place. Correct? When the medium changes, refraction, bending of light will take place. Refraction, right? So when the light travels from air to glass, refraction takes place. Again, at point O dash, the light is traveling from glass to air. Okay, the light is traveling from glass to air. So again, refraction takes place. How many refractions are taking place in this experiment? 2 times. 2 times the refraction is taking place. So the angle, so now at this point, for this point, O dash is incident ray, correct? And the angle made with the normal at the point of incidence O dash, let me call that as angle R2. Angle R2. Okay. Now, what is the refracted ray here? This is my refracted ray. Why? It is moving from glass to air, right? Glass to air. So this is my refracted ray. What is this angle? This angle, I'll call it as angle of emergence. Angle made by the refracted ray with the normal, okay, at the point of incidence, that is refracted ray, and I am representing it with angle E. Angle E. What do you mean by angle E? I'll explain. So before explaining that, so few things which I told that you should take, why you should take all pins, why the distance should be, okay, why the distance should be more than 3 centimeter. Let me explain that point. The distance between the pins should be 3 centimeters. The distance between the pins should be at least 3 centimeters. Better to take 4 centimeters, because in the experiment, when you are drawing this refracted rays, right, when you are drawing these rays, and you are judging the position of the rays, whether they are in a straight line or not, if you take more distance, the better will be your accuracy, better will be your judgment, and better will be your accuracy, better will be your result, and better marks you will get. So why you should keep at least 3 centimeter? To judge better whether, okay, to judge better. You have to see from this side and say whether these pins are in a straight line or not. To judge better, you have to keep the distance more than 3 centimeter. Okay. Now let's come here. Why I am calling this one as R1, this one as R2, and why I am calling it as E. So this is how the light entering the glass slab, and it is how it is where it is coming out. So when the glass slab when the light comes out of the glass slab, I am calling that as the light is emerging out from the glass slab. So this angle is called angle of emergence, and it is represented by angle E. What is angle of emergence? When the light comes out, goes into the glass slab and comes out of the glass slab, it is emerging away from the glass slab. So I'll call that angle as angle of emergence, so that you will not face any confusion. Clear? Why I'm calling it as angle of emergence? It is emerging out, coming out. It is coming out of the glass slab. So it is called angle of emergence. Okay, and this is R1, this is R2. Okay, here this why I have taken R1 and R2, because here R1 is angle of refraction for this point, correct, and this R2 is angle of incidence for this point. But since they are inside the glass slab, the angles inside the glass slab, I am representing it with R, letter R. Inside glass slab, I am representing it with letter R, R1, R2. Okay, R1 and R2. And one more thing, most important thing, if you really do the experiment very well, you will find that angle R1 is equal to angle R2, that angle of refraction which I am writing, which I will write here, three values I will write here. If you do the experiment properly, R1 will be equal to R2. R1 is going to be equal to R2. Clear? By maths also you can say, see, by mathematics how you can say, basic geometry. So these two lines are parallel. So this line O dash is transversal. So R1 and R2 are what? Alternate interior angles. They have to be equal. If they don't come to be equal, then you did some mistake. Your alignment was not correct with the pins. Clear? You can clearly understand where you have done the mistake. Your alignment with the pins was not correct if these two does not come equal. And one more thing. Whatever value you get here, angle of incidence, the same value you get here, angle of emergence. Whatever value you get here, same value you will get here. Angle of incidence is equal to angle of emergence. That is another important result of this activity. Angle of incidence equal to angle of emergence. If angle of incidence is not equal to angle of emergence, what does that mean? It clearly means that you have not done the experiment properly. Okay, 1 degree mistake can be ignored by the examiner. If you get more than that, angle E minus angle I, the examiner is going to cut your marks in the practical. It shows that you have not done, if you get more than 1 degree, it shows that you have not done the experiment properly. Do it again. Do the experiment again. Angle of incidence is equal to angle of emergence. Okay. So so this is your observation table. So what are the results? Let us discuss about the results. What are the results? Let us discuss about that. Number 1. You will find that angle of incidence is equal to angle of emergence. So whatever, if you take 30 degree, and here 30 degree. If you take 45 degree, here 45 degree. If you take 60 degree, here 60 degree. Angle of emergence equal to angle of incidence. Second part, R1 equal to R2 you are going to get. Okay, we are calling that as angle of refraction R. So these are the observations you are going to find. Let's understand what are the meaning of the first one. Angle of incidence is equal to angle of refraction. You understood, right? Angle of incidence is going to be angle of emergence. Angle of incidence is going to be equal to angle of emergence. So why? Let me explain why. See, when the light enters from air, it is traveling in a straight line, correct? Air is taken as homogeneous medium. As soon as it enters the glass, what would happen? It would shift. How it is shifting? How is that shifting? Let me draw the actual ray of light. So this is the actual ray of light. Okay. Clear? Okay, that is the actual ray of light. So when no glass slab is there, when no glass slab is present, the ray of light is going to travel this way. From here to here, see, PQO, then this dotted line, it is going to travel through in this way. if glass slab is absent. When glass slab is there, it is shifting towards the normal. It is shifting towards the normal. So what do you see? Angle I is greater than angle R1. What does that mean? Air is our rarer medium. Glass is denser medium. When the light travels from rarer medium to denser medium, it is going to bend towards the normal. It is going to bend towards the normal. When the light travels from rarer medium to denser medium, it is going to bend towards the normal. Clear? So this is your observation. Always I will be greater than R1. It has bent. Correct? Now, when the light is traveling through the glass slab, what you have seen, R1 equal to R2, R1 equal to R2, right? That means that the light is not bending through inside the glass slab, rather it is going straight. That means the glass is homogeneous inside. That means the glass is homogeneous inside and light travels in a straight line inside the glass slab. And where it is going to bend? It is going to bend when again it comes out from the glass medium to air medium. Again when it comes out from glass medium to air medium. Clear? So how much it is bending? You'll see that angle R2 will be less than angle E. Angle R2 will be less than angle E. What does that? Okay. What does that indicate? When the light travels from glass, that is denser medium, to the air, which is rarer medium, the light deviates. Okay, the light shifts away from the normal. That's why R2 is greater than E. R2 is greater than E. And what does this indicate? I is equal to angle E. What does this indicate? Now at point O, how much the light has shifted towards the normal? How much the light has shifted towards the normal? By the same amount, the light is traveling, shifting away from the normal. I'll repeat one more time. At point O, how much the light shifts towards the normal, with the same amount, the light is going to shift away from the normal at O dash. Clear? That's why this ray PQO, when I am extended here, and this ray O dash RS, both are parallel. This is also an important observation. How much the light is going to bend when it enters the glass medium, with the same amount it is going to bend away when it leaves the glass medium. Clear? That means that's why the refractive index of a medium is constant. This is the reason. Always sin I by sin R. The ratio is going to come constant. Why? Snell's law says sin I by sin R is constant. Why? Okay. By this observation, you can say that sin I by sin R equal to constant, or refractive index of a medium remains constant. For glass it remains constant. Clear? So y I is equal to E, the amount it shifts towards the normal at a refraction 1, that is when it travels from air to glass, the same amount it will shift away from normal at when it travels from glass to air. That's why this is equal. Now, most important thing which students ask again and again, what is that? What is lateral displacement? What is lateral displacement? So I am going to define lateral displacement. Okay, I am going to define lateral displacement. What is lateral displacement? Listen carefully. Okay, lateral displacement is the distance. Lateral displacement is the distance between the extended incident ray and emergent ray. Once again I am repeating. Lateral displacement is the distance. Lateral displacement is the distance. Let me denote it by LD. So this is LD. The lateral displacement is the distance between the extended incident ray. Right? The incident ray is up to PQO, that's it. So when I'm extending it right up to here, the extended incident ray and the emergent ray. What is emergent ray? O dash, R and S. That is emergent ray. So the distance between the extended incident ray and emergent ray, I am saying it as lateral displacement. Some people also call it as lateral shift. Why they call it as lateral shift? Light is shifting. Light is shifting its position. Light is shifting its position. It is supposed to move like this. Through this red dotted lines, it is supposed to move like this, but it has shifted. Correct? So that is called lateral displacement or lateral shift. That's why people call it as lateral shift. Lateral shift or lateral displacement, anything you can call it. Now the question comes, okay, generally in 1 mark question, they may ask, what are the factors on which the lateral displacement depends upon? What are the factors on which the lateral displacement depend upon? And they may give 4 options. Okay, they may give 4 options and you have to take any one of the correct one. So this question may be asked in exam for 1 mark. Okay, so let me explain what are the factors on which the lateral displacement depends upon. I suppose that the activity which I have shown here is clear. If it is not clear, please just let me know at what point it is not clear so that I can rectify it better, make it better. So I am writing here what are the factors on which lateral displacement depends. Okay, so this may be asked for 1 mark question. So first one, the lateral displacement depends upon angle of incidence. Lateral displacement depends upon angle of incidence. More the angle of incidence, more is lateral displacement. Angle of incidence, if it increases, lateral displacement will also increase. Okay, the relation between incident ray and lateral displacement is not important. What is important? To know that lateral displacement depends upon incident ray, that is important. How? Not important. So if angle of incidence increases, lateral displacement increases. If angle of incidence decreases, lateral displacement decreases. Clear? Number 2, it depends upon refractive index. Number 2, it depends upon refractive index. How it is going to depend upon refractive index? If refractive index increases, then lateral displacement is also going to increase. If refractive index decreases, lateral displacement will decrease. Clear? So how to check that? Yeah, first you have use a rectangular glass slab. Now remove it. Use another medium. Okay, another medium in this cuboidal shape. Take another medium. And if its refractive index is more than glass, then its lateral displacement will also be more. Okay, so refractive index, lateral displacement depends upon refractive index. Number 3, it depends upon thickness of glass slab. Okay, lateral displacement depends upon thickness of glass slab. So what is the thickness of glass slab? I am drawing here. So this is the thickness of glass slab. Okay, this is the thickness of glass slab. More the thickness, more is the lateral shift. More the thickness, more is the lateral shift, or lateral displacement will be more. Increase the thickness, lateral displacement will be more. So if I may take a bigger one up to here, suppose the side, this side AD, let me take it as bigger one. What would happen? Lateral displacement will increase. If I decrease the size, lateral displacement will decrease. Okay, and fourth important thing is it depends upon wavelength. It depends upon wavelength. If wavelength increases, okay, if wavelength, I think this is gravity. Okay, if wavelength increases, then lateral displacement will decrease. If wavelength increases, lateral displacement will decrease. Okay, wavelength increases, lateral displacement will decrease. Actually, this experiment we should do with monochromatic light. This activity should be done with monochromatic light. Why monochromatic light? Because each color has its individual characteristics, its individual wavelength. Red is having around 700 nanometers, 750 nanometers in between. So next, different colors. Orange a little less than that, yellow a little less than that, green less than that, and the least one is violet. So if I use violet light, what would happen? If I use violet light, what would happen? The lateral displacement, violet having less lambda, less wavelength, the lateral displacement is going to increase. If I take the red color, the lateral red having higher wavelength, so lateral displacement is going to decrease. Violet, lateral displacement increases. Red, lateral displacement decreases. Why we use monochromatic light? Because the refraction, that is the bending of light, is different for different colors, and when refraction takes place, colors split, and that's the process we call it as dispersion. Dispersion happens. Okay, so this type of activity generally done with monochromatic light, but you can do this. Okay, you can do this. So I hope the concept is clear. And one last point which I didn't explain, that why you should take an angle between 30 to 60 degrees. Why I am saying to take between 30 to 60 degrees. That's why my suggestion, you can take any angle, it's your wish, but I am saying to take 30 to 60 degrees. Why I am saying that? See, if you take more angle, let me shift like this. If you take more angle like this, so it will refract, and chances are that the light may refract through this side CB rather than AB. Okay, if you take more angle, then there is a chance that the light may refract through the side CB, not AB, and if then it will take place, then the emergent ray will not be parallel to the incident ray. I am repeating once more, if the light refracts to CB, then the light will not be parallel to the emergent ray. Sorry, let me explain it once more. If I take more angle, then the light emergent ray, okay, so emergent ray comes from, there's a fair chance that you will find emergent ray from here. So it may be making some angle, absurd angle. Okay, so emergent ray will not be parallel to incident ray. If emergent ray not parallel to incident ray, there is no lateral displacement, but there comes the concept of angle of deviation. So this lateral shift or lateral displacement is exclusive for rectangular glass slab or any material slab. It's exclusive for rectangular slab of any material. This lateral displacement is exclusive for any rectangular slab. So if it refracts here, okay, if it refracts through that, then it will not, this emergent ray will not be parallel to incident ray, so lateral displacement will not come. And you have to show lateral displacement. If you take more angle, then there are many chances that the light will refract through this way. That's why in the starting I gave two suggestions. One, to shift to the point O. The point I told you can take anywhere, but I told you to shift it towards D. towards left side. Why? So that the emergent ray will be formed on where? AB, the side which is parallel and opposite to CD. So emergent ray will be formed here. And another thing, why I told you to take this angle, this range, so that you can find lateral displacement. And why not? Why don't you take less than 30 degrees then? Why don't you take less than 30 degree? When you take less than 30 degree, the bending, shifting of light will be less. And your teacher who is examining your practical paper, he may find that this PQ line and this OO dash line are not refracting. Rather, he may assume it as straight line. There are chances for that. And he will reduce your marks. So in order to show the refraction clearly, take this range. More than 30 degree, less than 60 degree. So I hope I have explained all the things, and this experiment will be fruitful to you. If you have any doubts, just comment it. Okay, I'll surely explain that doubt. Thank you all.